Welcome to the integral of sine to the m of x times cosine to the n of x dx examples. So for our first example, let's evaluate the definite integral from 0 to pi over 3 of sine to the fourth of x times cosine to the seventh of x dx. So just a quick thing to note here, cosine is being raised to an odd power. So note we have an odd power on cosine. So this is a case where we will leave one cosine as is and convert the remaining to sine. So we're finding our indefinite integral first, or antiderivative first. So we are looking at the integral of sine to the fourth of x times cosine to the sixth of x times cosine of x dx. Again, this is the integral of sine to the fourth of x times cosine squared of x, that entire cosine squared then being raised to the third power, times cosine of x dx. Cosine squared is just 1 minus sine squared. So we are looking at the integral of sine to the fourth of x times 1 minus sine squared of x. That 1 minus sine squared, whole thing is cubed, and times cosine of x dx. At this point, we are set for our u substitution. So we set u to be equal to sine of x. Then we have that du is equal to cosine of x dx, which is precisely what we have on the end there. And so our integral becomes the integral of u to the fourth times 1 minus u squared, that entire 1 minus u squared cubed, times du. At this point, our job is to expand out our polynomial there. So if we now expand the polynomial, so we are going to expand and integrate. We are looking at the integral of u to the fourth times, we will have 1 minus 3u squared plus 3u to the fourth minus u to the sixth. Again, when we cube, we get 1, 3, 3, 1 as our coefficients. Because we are working with u squared, we get the even powers. And then since it's minus, we will alternate signs. Then we have du at the end. Multiplying in that u to the fourth, we are looking at the integral of u to the fourth minus 3u to the sixth plus 3u to the eighth minus u to the 10th du. Oops. Sorry about that. From here, Let me give myself a little more space. Right, from here, we have that this is equal to 1/5 u to the 5th minus 3/7 u to the 7th plus 3/9 u to the 9th minus 1/11 u to the 11th, and then plus c. Now we have two options. We can finish off our converting back into x, or we can convert our bounds into u for finding the definite integral. So I'm going to go ahead and convert the bounds to u and then evaluate the definite integral. So we had the integral from 0 to, I think, pi over 3. So the integral from 0 to pi over 3 of sine to the 4th of x cosine to the 7th of x dx. We set u equal to sine of x. So that means that x equals 0 corresponds to u equals sine of 0, otherwise known as 0. X equals pi over 3 corresponds to u equaling sine of pi over 3. And sine of pi over 3 is root 3 over 2. So we get that our integral is equal to the antiderivative we found in terms of u. We had 1/5 u to the 5th minus 3/7 u to the 7th plus 3/9 u to the 9th minus 1/11 u to the 11th. And we are going to evaluate from u equals 0 to u equals root 3 over 2. So this becomes 1/5 times root 3 over 2 raised to the 5th power minus 3/7 times root 3 over 2 raised to the 7th plus 3/9 times root 3 over 2 raised to the 9th minus 1/11 times root 3 over 2. Sorry, 1/11, not 1/10. 1/11 times root 3 over 2 raised to the 11th. And then plugging in 0, we would just be subtracting off 0. Let me update my screen so it shows that 1/11. And there we are. So again, we could simplify this a little if we wanted. I'm going to leave this as is and not bother simplifying at the moment. But of course, we could simplify. We would have a bunch of things we could combine with root 3s. We could combine the fractions out front. I'm just going to write simplify. And dot, dot, dot. All right, next up, let's go ahead and evaluate the indefinite integral. The integral of sine to the 4th x cosine squared x dx. So this is a case where these are both even. So note, both powers are even. So that means that we have to use our power reducing trick. So the power reducing trick that we have is that cosine squared of x is equal to 1/2 times cosine of 2x plus 1 and sine squared of x is equal to 1/2 of, in brackets, 1 minus cosine of 2x. So what we have then is we have our integral of sine to the 4th x cosine squared x dx is equal to the integral of sine squared of x, then that whole sine squared to get us to sine to the 4th, then times cosine squared of x dx. But sine squared we know, so we are looking at the integral of, in parentheses, 1/2, and then parentheses again, 1 minus cosine 2x. And both sets of parentheses, that's our sine squared of x, square that whole thing. Then we are going to multiply that by, in parentheses, 1/2 of, in parentheses, 1 plus cosine of 2x. And our parentheses, that's just raised to the first power since it was just cosine squared, and then dx. At this point, we go ahead and expand. So we have a 1/2 squared times another 1/2 is 1/8, which we can pull out front. So we have 1/8 times the integral of 1 minus cosine of 2x, that whole thing squared, times 1 plus cosine of 2x dx. Expanding, this is 1/8 times the integral of 1 minus cosine 2x squared becomes 1 minus 2 cosine of 2x plus cosine squared of 2x. And then we are multiplying that by 1 plus cosine of 2x. And then dx. Multiplying that out, we were looking at 1/8 times the integral of, we would have 1 times 1 is 1. Then we would have plus cosine of 2x. Then we would have a minus 2 cosine of 2x. And a minus 2 cosine squared of 2x. Then we would have a plus cosine squared of 2x. And a plus cosine cubed of 2x. And then dx. So this becomes 1/8 times the integral of. We would have 1 plus, we have a cosine 2x minus 2 cosine 2x. Will become a minus cosine 2x. Then we have a minus 2 cosine squared of 2x and a plus cosine squared of 2x. becomes a minus cosine squared of 2x. And we end with our plus cosine cubed of 2x dx. This essentially becomes 1/8 times the integral of 1 minus cosine of 2x dx. Then we have a minus 1/8 times the integral of cosine squared of 2x dx. And a plus 1/8 times the integral of cosine cubed of 2x dx. I broke this into 3 integrals because we still have some power reducing or tricks to play on the second 2 integrals, or the last 2 integrals. We can go ahead and just evaluate the first one. So we have the integral of 1 minus cosine of 2x dx. Integral of 1 just goes to x. Integral of cosine is sine. So we'll have a minus sine of 2x, except to counteract that chain rule, we should do a minus 1/2 sine of 2x. So we could do this with u substitution. If we set u equal to 2x. Or you can just do it knowing that it's a simple linear inner function, and that just results in dividing by the coefficient in front of the x. All right, then of course we have our plus c1 technically. For our second integral, we have the integral of cosine squared of 2x dx. This is an even power of cosine, technically an even power of sine. We will do power reducing. So this is even powers. And so we will go ahead and use the fact that cosine squared of 2x is equal to, let me move this down the line. Cosine squared of 2x is equal to 1/2 times, in brackets, 1 plus cosine of, in this case, instead of 2x, it'll be 2 times 2x, otherwise known as 4x. So we are looking at 1/2 times 1 plus cosine of 4x. So we get then that this integral is equal to the integral of 1/2 times 1 plus cosine of 4x dx, or 1/2 times 1 goes up to x. Integral of cosine is sine, so we'll have a plus, we'll have a sine of 4x. And then of course, to undo that chain rule, we have a 1/4 out front. And then plus a c2. Again, we could figure out this one by using u sub and setting u equal to 4x. And we would get this 1/2 times x plus 1/4 sine of 4x plus c2. Last up, we had our integral of cosine cubed of 2x dx. This is an odd power. And so we can do our case where we leave one cosine, convert the rest to sine. So we are looking at the integral of cosine squared of 2x times cosine of 2x dx, which again is of course equal to the integral of 1 minus sine squared of 2x times cosine of 2x dx. We will do u sub, setting u equal to sine of 2x. Then our du would be 2 cosine of 2x dx. Or in other words, that cosine of 2x dx we have on the end is equal to 1/2 du. So this becomes the integral of 1 minus u squared times 1/2 du. This becomes 1/2 times, in parentheses, u minus 1/3 u cubed. Then we have our plus c3. Plugging back in our u equals sine of 2x, we have this is equal to 1/2 times, in parentheses, sine of 2x minus 1/3 sine cubed of 2x, and then plus c3. So we wind up putting this all together, we had the integral of sine, what are we on? Sine to the 4th x cosine squared x. Dx is equal to, we had 1/8 times that first integral. So we have 1/8 times x minus 1/2 sine of 2x. Then we had minus 1/8 times the second integral. So we have minus 1/8 times 1/2 times x plus 1/4 sine of 4x. And then we finished off with plus 1/8 times our last integral. So we end up with plus 1/8. I'm going to shift this all up just a little so I can put it all on one page. Then we have plus 1/8 times 1/2 times sine of 2x minus 1/3 sine cubed of 2x. And then that whole thing will be plus c. We can, of course, simplify this a little bit. So this becomes, we have a 1/8 x, and then we have a minus 1/16 x will become 1/16 x. We have a minus 1/16 sine of 2x, and we have a plus 1/16 sine of 2x, which will cancel each other out. So I did the x's already. I did the sine of 2 x's. Then we have minus 1/16 times 1/4 becomes minus 1/64 sine of 4x. And then we have a plus 1/16 times a negative 1/3 becomes a minus 1/48 times sine cubed of 2x plus c. So you can see this is not the most pleasant integration to perform, but it is possible when we have even powers on both sine and cosine to evaluate the integral. It often requires multiple iterations of reducing powers to do so. Right, in the next videos, we will look at powers of secant and tangent.